Hello, I am Dr.Srinivasa, working as an assistant professor of physics in IDSG Government College, Chikmagalur. In this video, I am going to explain some concepts of nuclear forces, mainly the Mason theory of nuclear forces, which is a chapter for 3rd BSc physics students studying in 6th sem for Paper-8, Nuclear and Particle Physics, SSF 611. This is the video for session number 24. Mason theory of nuclear forces. That means how Yukawa explained the Mason theory to explain the nuclear forces. According to the Mason theory of nuclear forces, which is proposed by Yukawa, all nucleons consists of identical cores surrounded by a cloud of one or more nucleons. Very important. All nucleons consists of identical cores surrounded by a cloud of one or more nucleons. Mesons may be neutral or may have positive or negative charge. The sole difference between protons and neutrons is supposed to lie in the composition of their respective Mason clouds. Yukawa assumed that pi Mason is exchanged between the nucleons and that this exchange is responsible for the nuclear binding forces. That means nuclear force is mainly due to the exchange of pi Mesons between the protons and neutrons. For example, here there is a proton and proton, there is a neutron and neutron. So between proton and proton, between neutron and neutron, there is an exchange of neutral pi Meson. So here also this diagram shows how there is an exchange of Mesons between the proton and neutron. The forces that act between one neutron and another and one proton and another are the result of the exchange of neutral Mesons, that is pi Mesons. The force between a neutron and a proton is the result of the exchange of charged Mesons, that is positive pi Meson and negative pi Meson between them. Here this is very important. The forces that act between one neutron and another are one proton and another proton are the result of exchange of neutral pi Meson, that is pi neutral Mesons. This is very important. The force between a neutron and proton or between the proton and neutron is the result of exchange of charged Mesons. So maybe positive pi Meson or negative pi Meson between them. Here we can see that the proton is converted into neutron by a positive pi Meson. That is positive pi Meson plus neutron gives rise to proton. So protons decays to neutron by emitting positive pi Meson, or in the inverse process, this positive pi Meson combined with the neutron gives rise to proton. So you know that proton is a positively charged particle. So neutron is a neutral in nature. So this positive charge comes out as a positive pi Meson. According to the law of conservation of charge, proton is converted into neutron. So with emission of the positive Meson. Again, in the reverse process, this positive pi Meson combined with the neutron gives rise to the positively charged proton. Also you can see in this animated picture. So according to the elementary particles, the protons and neutrons are again made up of subatomic particles or elementary particles, called quarks. The proton consists of 3 quarks and also neutron consists of 3 quarks. The proton is made up of 2 up quarks and 1 down quarks, and neutron is made up of 2 down quarks and 1 up quarks. Proton is made up of 2 up quarks and 1 down quarks, and neutron is made up of 1 up quark and 2 down quarks. So between the quarks there is an exchange of particles, and also between the proton and neutrons also there is an exchange of pi mesons. See, this is the proton, this is the neutron. See, proton is converted into neutron by exchange pi neutrons. Again, neutron is converted into proton by exchange of pi mesons. Like that. Neutral, and also there is an exchange of particles between these quarks also. Again, Meson theory of nuclear forces, in neutron-proton interaction, neutron is converted into proton by emitting pi meson. In the last slide, you know that how conversion of proton into neutron by the exchange of positive pi meson, and also positive pi meson combined with the neutron gives rise to proton. In this slide, how neutron is converted into proton by emitting the negative pi meson. So here neutron is converted into proton in neutron-proton interaction by emitting negative pi meson. In the inverse process, pi meson combined with the proton gives rise to neutron. In proton-proton or neutron-neutron interaction, so proton is converted into proton by emitting neutral pi meson. Again, this neutral pi meson combined with the proton gives rise to proton. So this is proton-proton or neutron-neutron chain reaction. Similarly, between neutron-neutron, so a neutron is converted into neutron by the emission of neutral pi meson. Again, neutral pi meson combined with the neutron gives rise to a neutron. So this is neutron-proton interaction. This is proton-proton and neutron-neutron interaction. So proton-proton and neutron-neutron interaction is due to exchange of neutral particles, and proton-neutron interaction is responsible due to exchange of positive pi meson. Neutron-proton interaction is due to the exchange of negative pi meson. So as I explained in the last slide, you know that this is the nucleus, one nucleus, say proton, and this is the proton and this is the neutron. So around the neutron there is a field. So nuclear field. So there is an exchange of neutral pi meson. So this neutral pi meson is interact between the proton and neutron. The model above shows a proton and neutron with overlapping pion fields. This is overlapping pion fields, allowing the proton to donate a pion, that is neutral pi meson to the neutron, contributing to the nuclear force holding the two nucleons, that is protons and neutrons, together. Meson theory of nuclear forces continue. So as I explained, you know that a neutron emits a pi meson and is converted into proton. That is, neutron is converted into proton by emitting a negative pi meson. The absorption of pi meson by the proton to convert it into neutron, that is P plus pi minus, gives rise to neutron. In the reverse process, a proton emits pi meson, positive pi meson, becoming a neutron, and the neutron on receiving this positive pi meson becomes a proton, represented by this reaction. So proton is converted into neutron by emitting positive pi meson, and neutron is converted into proton by absorbing the positive pi meson. Thus, in the nucleus of an atom, attractive forces exist between proton and proton, proton and neutron and neutron. These forces of attraction are much higher than the electrostatic force of repulsion between the protons, thus giving a stability of the nucleus. Like this, Yukova explained the Meson theory of nuclear forces. From this we can calculate mass of the pi meson theoretically also. According to uncertainty principle, it is possible to estimate the mass of the meson, that is pi meson, as delta E into delta T is equal to h by 2 pi, according to uncertainty principle, where delta E and delta T are the uncertainty in energy and time. Let us assume that the meson travel between nuclei at approximately the speed of light c. This is the assumption. If the meson travels between the nuclei at approximately the speed of light c, let delta be the time interval between the emission of the meson from one nucleon and absorption of the other nucleon. Delta T is the time interval between the emission of meson from one nucleon and the absorption by the other nucleon. Then delta T is equal to R by C. That means time required is equal to distance travelled over velocity. Here distance travelled is given by R, that is range of the meson, and C velocity of light, and delta T is the uncertainty in time. We know that according to uncertainty principle, we can measure the energy of the pi meson, as we know that delta E into delta T is equal to h by 2 pi. So delta E is equal to h by 2 pi over delta T, and also substitute for delta E is equal to m naught c square. Therefore, the minimum meson mass is specified by, so m should be greater than or equal to h by 2 pi rc. So if you substitute m naught c square for delta E, here m naught c square is equal to h by 2 pi into delta T, and substitute for delta T as r by c. 1 c and 1 c get cancelled, we get m or mc square. So h by 2 pi over rc, and substituting r by c for delta T, and delta E can be written as mc square also. In terms of the electronic mass Me, the mass of the meson is given by m by Me is equal to, so Me is h by rc, h by 2 pi over rc, and m is also h by 2 pi over rc. So m by mc is equal to h by 2 pi over Me into rc. Substitute all the values. So the Planck's constant value, reduce the Planck's constant value, mass of the electron, and range of the meson E as 1.4 into 10 power minus 15 meter, and C value 3 into 10 power 8. In the next slide, we will going to calculate the range of the pi meson also. The range of the pi meson calculated is about 1.4 femtometer. Substituting all this value after simplification, we get, so mass of the pion is about 275 times the mass of the electron. That is, mass of the meson is equal to 275 times the mass of the electron. This is the theoretical value of the pi meson. In 1947, Powell discovered experimentally pi meson of mass about 273 times the mass of the electron. So this is theoretical value and this is the experimental value. The experimental value is in close agreement with the theoretical value. Therefore, the Meson theory proposed by Yukova is found to be correct. That is, nuclear force arises due to the exchange of pi meson. This particle showed strong interaction with nucleons and was recognized as the Yukawa particle, because for the first time this particle was proposed by Yukawa. Hence pi meson is also called Yukawa particle. We can also calculate the range of the meson. You know that just as a photon has a quantum of electric field, a meson is a quantum of nuclear field. This is very important. Photon has a quantum electromagnetic field. A meson is also considered to be quantum of nuclear field. What is the quantum of nuclear field? The quantum of nuclear field is a meson or pi meson. Yukawa considered the equation for particle of mass m as del square minus m square c square over h by 2 pi whole square minus del square by c square del t square into phi is equal to 0. This is a relativistic equation valid only for spinless particle, because meson has no spin but it has a mass. Separating the time dependent part, the equation for radial part is given by del square minus mu square into phi of r is equal to 0. Call this as the equation 2, where mu is equal to mc over h by 2 pi. The solution for that equation 2 is phi of r is equal to minus g e to the power of minus mu r over r. So there is a large calculation and substitution and approximation. After that we can obtain the solution for that equation. Here g is the constant which plays the same role as the charge q in electromagnetic theory. In analogy with electromagnetic spectrum, the potential between two nucleons is given by V of r is equal to minus g square e to the power of minus mu r over r. Here g square is called the coupling constant. This argument made Yukawa predict the existence of pion as a quantum of nuclear force field. In analogy with electromagnetic spectrum, the potential between two nucleons is then given by V of r is equal to minus g square e to the power of minus mu r by r, the same equation 4. So you already know that the range of the pion field is given by r is equal to h by 2 pi over m naught c square. Substituting all the values, m naught c, all the values, and after simplification we get the range of the pion field as 1.4 femtometer or Fermi, as I substitute and explain in the last slide. The form of V of r is given by equation 4 is known as one pion exchange potential. So this is how Yukawa explained meson theory to explain the nuclear forces, gives rise to stability of the nuclear forces or nucleus. These are the books I have used to make this video. Thank you for watching. Thank you once again.